Imagine waking up tomorrow, opening your phone, and reading a headline that says, "A Chinese AI chip is now up to 478 times faster than NVIDIA." Be honest, your first reaction would probably be, there's no way that's true. Maybe it's clickbait. Maybe someone misunderstood the benchmark. Or maybe it's just another exaggerated headline designed to go viral. But here's the shocking part. The headline is based on a real breakthrough, not from a startup trying to grab attention, not from an anonymous source on social media, but from researchers at Peking University and the Chinese Academy of Sciences. And for the past few weeks, this announcement has quietly started making people across the semiconductor industry pay very close attention. Because if even part of these claims hold up, they could change how we think about AI hardware. Now, before you get too excited, let's clear up one thing immediately. This does not mean China has built a chip that's 478 times faster than every NVIDIA GPU in every situation. That's not what the researchers are claiming. In fact, the real story is much more interesting than that, because this isn't a normal computer chip. It isn't trying to compete with NVIDIA by playing the same game. It's trying to change the game entirely. For years, the entire AI industry has been built around one idea. If you want faster artificial intelligence, you need more powerful GPUs. That's exactly why NVIDIA became one of the most valuable companies in the world. Every major AI model, every massive data center, every breakthrough you've heard about over the past few years, almost all of them depend on powerful graphics processors. Companies are spending billions of dollars buying them. Governments are racing to secure them. And demand has become so high that some organizations have waited months just to get access to enough AI hardware. For a long time, it looked like there was only one path forward. Build bigger GPUs. Buy more GPUs. Connect thousands of GPUs together. Repeat. But what if that's not the only path? What if instead of making the engine bigger, you designed an entirely different engine? That's exactly what a team of Chinese researchers decided to explore. Instead of asking, how do we build a faster GPU? They asked a completely different question. What if AI didn't need to think like today's computers at all? That single question led them towards something inspired by the most powerful computing system we know, the human brain. Now don't worry. This isn't going to turn into a complicated engineering lecture, because the basic idea is surprisingly simple. Your brain doesn't work like a graphics card. It doesn't constantly move information back and forth between separate places for processing and memory. It does many of those things together at the same time, using billions of interconnected neurons. And that's one reason the human brain can perform incredibly complex tasks while using only about as much power as a small light bulb. Compare that to modern AI servers. Some consume thousands of watts just to perform calculations. That's a massive difference. And for years, scientists around the world have been asking the same question. What if computers could work a little more like brains? That's where this new Chinese chip enters the story. It isn't simply faster because someone increased the clock speed. It isn't simply more powerful because someone added more transistors. It's based on an entirely different way of processing information, one that's been studied for years, but has remained incredibly difficult to build. And according to the researchers, their latest breakthrough produced results that surprised even experienced engineers, results that sparked headlines mentioning numbers like 50 times faster, even 478 times faster. Those are extraordinary claims, and extraordinary claims deserve extraordinary explanations. So before anyone declares that NVIDIA has been defeated, we need to answer one critical question. How can a chip possibly become hundreds of times faster than one of the most advanced AI processors on Earth? Because once you understand what this chip is actually doing, those unbelievable numbers start making a lot more sense. And that's where this story becomes truly fascinating. So, how can any chip be 478 times faster than NVIDIA? At first, it sounds impossible. After all, NVIDIA didn't become the world's AI leader by accident. Its GPUs power everything from ChatGPT to self-driving cars, scientific research, robotics, and some of the largest AI data centers ever built. So how could a research team suddenly build something hundreds of times faster? The answer lies in one very important detail. This new Chinese chip isn't trying to replace a GPU by doing the exact same job. It's trying to solve a completely different problem, in a completely different way. Think of it like this. Imagine two people are asked to travel across a city. One chooses a sports car, the other chooses a helicopter. Now, if the destination is on the other side of heavy traffic, the helicopter wins easily. Does that mean helicopters are better than cars at everything? Of course not. Each one was designed for different situations. That's exactly what's happening here. Modern GPUs are incredibly powerful. They're built to perform massive amounts of mathematical calculations over and over again. That's why they're perfect for training today's giant AI models. But the researchers behind this new chip weren't asking, how do we build a better GPU? They were asking something much more ambitious. What if we stopped thinking like traditional computers altogether? To understand why that's such a big deal, let's look at something you use every single day, your brain. Right now, without even trying, your brain is recognizing my voice, understanding language, predicting the next sentence, remembering information, filtering out distractions, and doing all of it while using only about 20 watts of power. That's less electricity than many household light bulbs. Now compare that to a modern AI server. Some consume thousands of watts, not because they're inefficient, but because traditional computers work very differently. A normal computer stores information in one place, processes it somewhere else, then sends the results back again. And it repeats that process, or even billions of times. Imagine having to walk across your office every single time you needed a single piece of paper. You'd spend more time walking than working. That's one of the biggest challenges engineers have been trying to solve for decades. Moving data around takes time. It also consumes enormous amounts of energy. Now imagine something different. Instead of separating memory and computation, what if they happened in almost the same place? What if the chip could remember information and process information at nearly the same time? That's the idea behind the technology used in this breakthrough. The researchers built their system around devices called phase change memristors. Now, don't let the name scare you. You don't need to remember it. Just think of them as electronic components that behave much more like biological connections inside the brain than traditional computer memory. Instead of constantly moving information back and forth, they can help combine storage and computation much more efficiently for certain types of problems. And that's exactly why this research is attracting so much attention. Because if you reduce the need to move data around, you reduce delays, you reduce energy consumption. And for specific AI tasks, you can achieve dramatic performance improvements. That's where those incredible benchmark numbers come from. Not because the chip breaks the laws of physics, not because NVIDIA suddenly became obsolete, but because the researchers changed the way the problem was being solved. It's a completely different approach. And sometimes, changing the approach matters more than simply making existing hardware faster. History is full of examples like this. Airplanes didn't become successful because someone built a faster car. Smartphones didn't replace computers because someone built a bigger keyboard. They succeeded because they solved problems differently. This new AI chip could represent that same kind of shift, not an upgrade, a new direction. But here's where things become even more interesting. Building an experimental chip inside a research laboratory is one thing. Turning that breakthrough into technology that changes the AI industry is something entirely different. And that's the question researchers, governments, and technology companies around the world are now asking. Can this breakthrough stay inside the laboratory? Or could it eventually power the next generation of artificial intelligence? Because if the answer is yes, this announcement may turn out to be far more important than today's headlines suggest. And that's exactly where the story takes another unexpected turn. So, let's imagine for a moment that this technology continues to improve. Not next week, not next month, but over the next 5 to 10 years. What could that actually mean? Would it simply make AI faster? Or could it change the way artificial intelligence is built altogether? Because here's something most people don't realize. The biggest challenge facing AI today isn't just intelligence, it's electricity. Every time a powerful AI model answers a question, generates an image, writes code, or analyzes massive amounts of data, an enormous amount of computation happens behind the scenes. That computation requires energy, lots of it. And as AI models become larger and more capable, their appetite for computing power keeps growing. That's one reason technology companies are investing billions of dollars into new data centers. They're not just building bigger buildings, they're building the infrastructure needed to feed the next generation of AI. Now imagine if future AI hardware could perform certain tasks using only a fraction of today's energy. That wouldn't just reduce electricity costs, it could completely change where AI can exist. Think about your smartphone. Today, many advanced AI features still rely on cloud servers. Your request travels across the internet, gets processed inside a data center, then the answer comes back to your device. But if future chips become dramatically more efficient, more AI could happen directly on the device itself. Faster responses, lower power consumption, less dependence on constant internet connections. That's a future many researchers have been working toward for years. Now think even bigger. Let's go back to something we've talked about before on this channel, humanoid robots. Right now, one of the biggest challenges facing advanced robots isn't simply making them walk. It's allowing them to think and react quickly while using limited battery power. A robot can't carry a giant AI data center on its back. It has to process information efficiently, while standing, walking, balancing, recognizing people, avoiding obstacles, and making decisions in real time. That's incredibly demanding. Imagine if future generations of AI chips could help robots perform those tasks more efficiently. Suddenly, robots become more practical. Not because they're smarter overnight, but because they're using their available energy more effectively. The same idea applies to autonomous vehicles, drones, medical devices, factories, even satellites. Anywhere computing power is limited, energy efficiency becomes just as important as raw speed. And that's exactly why researchers around the world are exploring alternatives to traditional computing architectures. Because the future isn't only about building faster processors, it's about building smarter ones. Now, does this mean every NVIDIA GPU will suddenly become obsolete? Today's AI ecosystem still depends heavily on GPUs. Training the world's largest AI models requires extraordinary computing power, and NVIDIA remains one of the industry's undisputed leaders. But here's something history has taught us again and again. Dominant technologies don't stay dominant forever simply because they arrived first. They stay dominant by continuing to innovate. That's why breakthroughs like this matter. Not because they replace today's technology overnight, but because they push the entire industry forward. Competition creates innovation. Innovation creates better technology. And better technology benefits everyone. That's one reason announcements like this receive so much attention from engineers and researchers. They're not asking, is NVIDIA finished? They're asking something much more interesting. Could this become another important tool in the future of AI computing? Because the future probably won't belong to just one type of processor. It may belong to many, each designed for different jobs, each solving different problems. And if that happens, the AI industry of the next decade could look completely different from the one we know today. But before we jump too far into the future, there's one final question we need to answer. After all the headlines, after all the excitement, after all the talk about being hundreds of times faster, what does this breakthrough actually mean today? Is this the beginning of a revolution? Or are we still looking at the first chapter of a much longer story? That's where everything comes together. So, after everything we've covered, let's go back to the headline that made people stop scrolling. China's new AI chip is up to 478 times faster than NVIDIA. Now you know something most people don't. That headline is both incredible and incomplete. Because if someone tells you this new chip is faster than NVIDIA at absolutely everything, that's simply not true. And if someone tells you this breakthrough doesn't matter because it's just a research project, that isn't true either. The reality sits somewhere in the middle. And honestly, that's what makes this story so fascinating. This chip wasn't designed to replace every GPU sitting inside AI data centers around the world. It wasn't designed to run every AI model that's being trained today. Instead, it proved something much bigger. For decades, most people believed there was only one direction AI hardware could go. Build bigger chips, use more transistors, consume more electricity, connect more GPUs together. Repeat. This research asks a completely different question. What if the future of AI doesn't have to follow that path? That's why engineers are paying attention. Because sometimes, the biggest breakthroughs don't arrive as finished products. They arrive as proof that a completely different idea actually works. Think back to the very first electric car prototypes. They weren't better than gasoline cars overnight. The first smartphones weren't more powerful than desktop computers. The first artificial intelligence systems couldn't do even a fraction of what modern AI can accomplish today. But each of them proved one thing: the future was possible. That's exactly where this new chip stands today. It isn't the end of the story. It's the beginning of one. And perhaps that's the biggest reason this announcement matters. Not because NVIDIA suddenly lost its position, not because every AI company is about to replace its hardware tomorrow, but because the conversation has changed. Until recently, the question was, how do we build bigger GPUs? Now another question has entered the discussion. Can we build AI hardware in an entirely different way? Those two questions may shape the next decade of computing. Now let's zoom out for a moment. Over the past few months, we've covered story after story coming out of China. Humanoid robots that move so naturally people think they're fake. Companies racing to make robots more affordable. New AI models competing with some of the biggest names in the industry. And now, researchers exploring an entirely different approach to AI computing. Each story might seem unrelated, but together, they reveal something much bigger. China isn't focusing on just one piece of the technology puzzle. It's investing across the entire ecosystem: artificial intelligence, semiconductors, robotics, advanced manufacturing. Each breakthrough strengthens the next. And that's exactly why the world is watching so closely. Because leadership in technology has never been decided by one invention. It's decided by years of continuous innovation. One breakthrough after another, one experiment after another, one improvement after another. Whether this particular chip becomes the foundation of future AI systems, or simply inspires the next generation of researchers, it's already accomplished something important. It has forced the industry to ask new questions. And in science, the right question is often just as valuable as the answer. So, the next time you see a headline claiming that China has built a chip hundreds of times faster than NVIDIA, don't immediately believe it. But don't dismiss it either. Instead, ask a better question. Faster at what? Built for what? And what could this technology become 5 years from now? Because those are the questions that really matter. Today's headlines come and go, but breakthroughs like this, whether they succeed or fail, shape the direction of tomorrow's technology. And history has shown us something remarkable. The technologies that change the world rarely look world-changing in the beginning. They often start inside laboratories, hidden inside research papers, long before they become products that millions of people use every day. Maybe that's exactly what we're looking at today. Not the end of the AI hardware race, but the beginning of its next chapter. And if that chapter unfolds the way many researchers hope, the future of artificial intelligence may look very different from the one we imagine today. So the next time someone says, China's new AI chip is 478 times faster than NVIDIA, you'll know the real story, not just the headline. And in technology, understanding the story behind the headline is often far more valuable than the headline itself. If you enjoyed this deep dive and want more fact-based breakdowns of the biggest breakthroughs shaping the future of technology, subscribe to Byte Dynasty. Because the next breakthrough could already be happening. And when it does, we'll break it down for you.